And the final part of this preliminaries here deals with another important type of proof, and that is proving by mathematical induction, or simply proving by induction. So I'm out of pages, so let's just add more. There. Okay. So just to recall, let's define what is proving by induction first. If a set S is some subset of the set of natural numbers such that first, the set S contains 1, and second, whenever S contains a natural number n, it also contains the natural number n plus 1, then we say that S must be equal to n. Or it must be that S is equal to n. And that's the idea between proving by induction. And let's prove the following in this example. Now, we let x1 be equal to 1, and we define x sub n plus 1 be equal to 1/2 times xn plus 1. That's for all natural number n. Now, we want to show that the sequence defined by x sub n is increasing. Or equivalently, we want to show that x sub n is less than or equal to x sub n plus 1 for all natural numbers n. So let's prove this by induction, because normally when we use induction when a certain claim involves indexing in terms of natural numbers. Okay, so to prove I, let's show that this claim is true for n is equal to 1. And that's the very first step, because if it's not true for n is equal to 1, then it cannot be true at all for any natural number n. So first, by definition, we let x1 be equal to 1. And let's define compute x sub 2 by that definition is equal to 1/2 x1 plus 1, which is equal to 3/2. And clearly, x2 is less than or equal to x1. Then the statement I is true. Now let's prove the second bullet. So let's say if the claim is true for a natural number n, then it must be true for n plus 1. To prove it, requires showing this one. In other words, if x sub n is less than or equal to n plus 1, then, now this is a statement for n, then if we replace n by n plus 1, then it must be true. So that's x sub n plus 1 be less than or equal to x sub n plus 2. That is for n plus 1. Now, let's start with this. Suppose x sub n is less than or equal to n plus 1. Now, let's try to arrive this one and arrive in such a way that we get x sub n plus 1 on the left side. And how to do that is this. You can simply multiply both sides by x sub 1/2, 1, and then add both sides by 1. Okay. So therefore, the left-hand side goes like this. So from the definition of x sub n, notice that the left-hand side is just x sub n plus 1, which is less than or equal to x sub n plus 2. And that proves part 2 of the claim. Now we have discussed all some preliminaries that, the main preliminaries that we need in this course. Then we can now proceed with the formal topics in analysis. So I will see you on the next meeting. Thank you.